I am Dr. Rizwan, and this is my friend and colleague Dr. Vijay Geeta. At the outset, I would like to thank you all for giving us an amazing response and feedback on the last session, and I hope you will provide a similar feedback for this session as well.
Hi all, so today we will discuss about confidence intervals. So as always, I request you all to kindly post in your questions in the chat box and we will try to answer as many of them as possible. I also request you to kindly give in your valuable feedback which is again given in the description of the video here. So let's begin then, shall we? So hi Dr. Riz.
Hi.
So I read this trial on the effectiveness of remdesivir in reducing mortality among moderate COVID-19 patients. So they have reported the following results. So applying what was discussed in the last session, I know that to compare the day 28 mortality between the remdesivir and the placebo group, the authors have performed a statistical test and arrived at a p-value which is 0.74. Based on the arbitrary cutoff of 0.05, the p-value indicates a lack of statistical significance. I know that this p-value gives us a glimpse of whether an association is significant or not, but not the magnitude of the association. As readers, we should always remember to look at clinical significance of the reported relative risk of 1.1. I was just wondering, how can I be sure that what was reported in the study is equal to or similar to the truth?
So, I'm glad that you went back and read Dr. Vijay. That was really a nice explanation. So, when you were explaining, you casually said the word truth, right? So, we need to understand and define truth first. In the world of statistics, truth has got a definite meaning, okay? Truth is that value or result which we will get if we included the entire eligible population in a perfectly designed study. So, this truth is fixed, that is, there is only one true answer for a given research question. But the problem, you know what, we don't know this true value, right? So, that is why we do the research study to find out this truth. So, when you were talking about this truth, you said a study was conducted, right? So, practically speaking, we cannot include the entire population, right? So, we take a sample, we do the study and get an approximate estimate of this truth, and we try to extrapolate this result to the population. This is what is called inferring the result from the sample to the population.
Okay, I get it. So you say it is an approximate estimate. So that leaves me wondering, how accurate is this estimate and how can I find it from the results?
Very good. So this is called uncertainty in research studies, and as researchers, we are never sure 100% of the times that this is the value that is equal to the true value. So, in the randomized control trial where the remdesivir drug was used to check on COVID-19 or reduce COVID-19 mortality, shall we take a closer look at the example?
Yes.
Okay. In this study, if you see, the relative risk is used, or risk ratio as they say, is used to denote the results, right? Here you can see for day 28 mortality, the relative risk that has been used is 1.10. So here the relative risk is 1.10. What does this relative risk mean? Relative risk tells us whether individuals with a given exposure have higher risk or lower risk of having the outcome. So here the relative risk is 1.10, which indicates that people who took the remdesivir drug or the group which received the remdesivir drug had higher chance of mortality compared to the people who received the placebo group. So in other words, the increased mortality in the remdesivir group was 10% higher than in the placebo group. Dr. Vijay, did you notice that along with the relative risk of 1.10, two other values are given within parentheses, 0.63 and 1.93. What do you make of it?
Does the true value range from 0.63 to 1.93?
Not quite, Dr. Vijay. To understand this, the confidence interval as they say, we need to conduct a thought experiment. Okay, so imagine we repeat this remdesivir trial 100 times. Okay, and each time from each study we get one relative risk and one confidence interval. So now we have 100 relative risks and 100 confidence intervals. Statistical theory tells us that 95 out of these 100 confidence intervals will capture or contain the true value. Let me show you a figure. So this is a simulation or a computer program which helps us understand confidence intervals. In reality, no one is going to do 100 studies, so let us do a computer simulation. So here you can see this green vertical line, that is called the true value. In practice, do we know this value, Dr. Viji?
No, we do not know this value.
Okay, so for the sake of assumption or argument, we will say that this green line represents the true value, but we do not know in practice. And these black dots represent a repetition of the study. Okay, and the horizontal black lines which cross the black dots are the confidence interval for each study. So this is study 1, this is study 2, this is study 3, this is study 4, etc. So here I have shown you 20 repetitions instead of 100 for the lack of space. Okay, so these 20 studies are just repetitions of the remdesivir trial. You can see here, out of the 20 studies, 19 studies cross the green line or they contain the true value. So Dr. Viji, what will be the value if we had done it for 100 studies?
It would be 95 out of 100.
Yes, correct. And you can see that this red guy does not include the true value or it does not cross the green line. So this is called going away from the truth, and the possibility of this is less than 5%, that is less than 1 in 20. So this, in other words, confidence interval tells us the degree of uncertainty of a given result.
So that's why we call it the 95% confidence intervals.
Spot on. So now one more question to you. I said 95 out of 100 confidence intervals or studies include the true value. But what about the 5 studies which do not include the true value?
Yes, so you earlier said we can never be 100% sure in research. We do not know the true value because it is unknown. Wait, Dr. Riz, this 5% of the studies that are far away from the truth, does it have any relation to the 5% level of significance that we set for p-values?
Yes, of course, and very clever of you to point that out. This 5% is called the error, and as scientists and researchers, we are okay with this level of error. Sometimes you might not be okay with this level of error and you might want to reduce this error level. But conventionally speaking, in biomedical research, we calculate 95% of confidence, 95% confidence intervals.
So if somebody asks me to define 95% confidence interval, I should say that if the same study is repeated 100 times and a confidence interval is calculated for each time, then 95 of those 100 confidence intervals will capture the true value.
Yes, you are right. So this is the definition that we recommend. But you should remember there is another definition which you might come across when reading textbooks, which says that we are 95% confident that this interval contains the true value. But we generally don't recommend that definition. What you said was more appropriate statistically speaking. So now Dr. Viji, you know the interpretation and definition of confidence interval. Can you go back to the remdesivir trial and try to interpret the confidence interval which was given there?
Sure, Dr. Rizwan. So, okay, we say individuals who were given remdesivir had 1.1 times higher risk of mortality as compared to the control group, and the interval 0.63 to 1.93 will capture the true value 95% of the times.
Absolutely.
So, what if the relative risk is 1? What does it mean?
Good question, Dr. Viji. So, a relative risk of 1 means that the mortality was equal in both the groups, both the remdesivir group and the control group. The same number or the same proportion of people died in both the groups. That is why when you divide the incidence in one by the other, you get the value 1. This 1 is called null value. In statistical terms, we call it null value. For relative risk and odds ratio, which are fractions, the null value is 1. But for risk difference or mean difference, where we subtract two quantities, the null value will be
0.
Very good.
So, putting your explanations together, I cannot help but notice that in the remdesivir example, the confidence interval contains the null value of 1 for relative risk. So, does it mean that the true value could be 1? And in that case, wouldn't it mean that there is no significant difference between the two groups?
Spot on, VG. You are correct on both the counts. So this is how sometimes without the p-value we can say whether a result is statistically significant or not by merely looking at the confidence interval. If the confidence interval contains the null value, which is 1 in case of a relative risk, if you see the remdesivir trial, it started at 0.63 and went up to 1.93, which means it includes 1. So we say that the result is not statistically significant.
Thank you, Dr. Riz. It's very clear now. So the other day, one of my friends was mentioning that she has got a very wide confidence interval in her study, where she was studying the prevalence of autism among children. What does this mean?
Okay, before I answer your friend's question, I have to make one thing clear. So confidence intervals are not only for relative risks, they can be calculated for any statistic that is calculated from a sample and our objective is to extrapolate or infer this to the population. So confidence intervals can be calculated for odds ratio, relative risk, hazard ratio, and even incidence, prevalence, and area under the curve, etc. So in your friend's example, she has calculated the prevalence of autism among children. So this is a single quantity, there is no comparison between two groups. So when we talk about the width of the confidence interval, the width is an indicator of the precision of your study. How accurate are you estimating the truth? A narrow confidence interval means that you are more precise or we are more confident of the results, whereas a wide CI indicates that there is more uncertainty in your results and there is the results are not as precise as you would like it to be.
Dr. Riz, can you give me an example?
Okay, for that let me switch to the writing board. Let me give you an example. So, in the remdesivir trial, let us say there was study A and study B and they reported a relative risk. Let us assume that both of them reported a relative risk of 5, right? And for the 95% CI, let us assume that the first study reported a confidence interval of 2, 8 and the second study reported a confidence interval of 4 and 6. So, looking at these two confidence intervals, that is 2, 8 and 4, 6, which of these two studies do you think is more precise, Dr. VG?
I think the second one is more precise.
Why do you say so?
Because the interval between the upper limit and lower limit is 6 in the first example, while it is 2 in the second example. So therefore, we are estimating the true value with more precision in the second example.
Very good, Dr. VG. So, a narrow precise or a narrow confidence interval gives you a limited range of the possibility of true values, whereas a wide confidence interval gives you more options for the true value. So, this is why we prefer a narrow confidence interval or a more precise confidence interval. So, Dr. VG, remember 3 things. Whenever you come across a confidence interval in your paper or in your study or in your thesis, you have to remember 3 things. Number 1, if it is a comparison situation where you are comparing two groups, remember to see whether the confidence interval includes the null value, which is 1 for a relative risk odds ratio or 0 for mean difference or risk difference. Number 2, look at the width of the confidence interval. Make sure that that width is precise enough for you. And the third thing is, remember to see whether this result is clinically relevant to you or not, either the lower limit or the upper limit. If the lower limit or the upper limit of the confidence interval is very close to the null value, it means that we are not very sure or not very confident of the results.
Okay, Dr. Riz. So what is the statistical theory behind this that makes us this assumption?
So hang with me on this one. So the statistical theorem is called central limit theorem. This theorem tells us that if you take sufficiently large number of random samples from the population, the result from each study, if you plot them, they will follow an approximately normal distribution. If that went over the head, I am with you. Okay. So, but the thing to remember is this theorem tells us how to calculate standard error. Now, standard error is the thing that we plug into the formula to calculate a confidence interval. Confidence interval is nothing but result plus or minus 1.96 standard errors. So, but that's for a later session. For the time being, just remember that this theorem helps us to calculate standard error, which goes into the formula for confidence intervals.
Okay, thank you, Dr. Is. So I'll summarize whatever we discussed today for our viewers then.
Sure.
So p-values have certain limitations because they do not quantify the strength of the association. Confidence intervals are a better way or an improved way of reporting the results, where along with the result, we also we give an interval which is likely to contain the true value. And 95% of the confidence interval, 95% confidence interval means if we repeat the study several times with the same sample size, 95% of those studies will have a confidence interval that will capture the true value.
True value.
So we will now answer some of the chat questions.
Okay, let me go through the chat questions and we will try to answer some of them. If you have a question, please type in your question in the chat window so that we can answer some of them. So, Dr. Vadivelu is asking, when can confidence interval be too wide? This is Dr. Lalita Fernandez asks, when can confidence interval be too wide? Okay, so the width of the confidence interval is a function of the sample size, Dr. VG. So, if your sample size is not calculated a priori, that is before conducting the study, and if you end up with a small sample size, your confidence intervals are likely to be wide. And second thing is, if the variation in your sample is high, that is you have included very widely varying samples, then also your confidence interval is likely to be wide. So there are two functions that you need to remember. One is the sample size and the second thing is the variability in your sample. Dr. Vadibel asks, if the parameter does not follow normal distribution, can we still use 95% confidence interval? Now that is a tricky question, isn't it? So normally we follow generally speaking we follow normal distribution, but if you have reason to believe that your data does not follow normal distribution, we might have to depend upon other formula of confidence intervals which are called by different names. In that case you will no longer have symmetrical confidence intervals, that is below and above the estimate you will not have the symmetry, the values will not be equal. There are other ways of calculating 95% confidence interval which do not depend upon the central limit theorem. A very good question.
So we have another query from Dr. Shanti Adhikari. What is effect size any relation with confidence interval?
Okay, so effect size is the estimate or the result that we get, the relative risk. Okay, so that is called the effect estimate. The single value or the point estimate that you get is called the effect size. The values which go on either side of the effect size are called confidence intervals.
So
one more question. Can you please explain the concept of relative risk and null value? Okay, so relative risk is as you know is a fraction, right? On the numerator you have incidence among the exposed group and on the denominator you have incidence among the non-exposed group. So if the incidence among the exposed group is higher, you will get a relative risk of more than 1, and vice versa if you have relative risk of less than 1. Null value is 1 because if the incidence in the numerator is equal to the incidence in the denominator, that is exposed and unexposed groups, you will have a relative risk of 1. Null, that is called null value, which means the incidence is equal in both the groups. That is what we mean by null value.
what is the relation between p-value and confidence interval?
Okay, so that one is a good question, we will answer that. So what is the relationship between
P-value and confidence
p-value and
interval.
confidence intervals? Both of these share some characteristics. Okay, as we said, p-value comes from a statistical test. You do a statistical test like chi-square test or t-test or ANOVA and you get a single value which tells you whether the result is statistically significant or not. Confidence intervals on the other hand give you an interval on either side of your result, that is the effect size, which may be relative risk in your case. So both of them agree in most of the cases, that is if you get a significant p-value, the confidence intervals will also be significant, but not always. This is the relationship between confidence intervals and p-value. This is a statistical test and this is a quantitative way of saying whether your results are significant or not. Do you say p-value is less significant than Ci? I think that is a misnomer or you can say misinterpretation. p-values have their place in research. Okay, they were initially used, but then a lot of people started misusing or abusing p-values. If you read our resource in the last class that we had given, you could understand that p-values are misused and abused a lot of times. But nowadays we depend more on the confidence intervals. There is nothing like p-value is less or high or less significant or more significant than confidence intervals, but generally confidence intervals gives more information. It tells you what the actual true value in the population might be. So it is more informative than the p-value, which simply tells you whether the result is statistically significant or not. So in that case, in that sense, confidence interval is having much more information. CI less than 95%, what does it mean? There is no such thing as CI less than 95%. As I said before, this 95% CI can be changed to different levels. So in papers you might come across 99% CI, 98% CI, 80% CI. So that is the level of confidence we want in the result. But conventionally speaking, across biomedical literature, you will see 95% CI.
So we have one question from Dr. Abhinav. If a normal distribution curve is skewed to any side, positive or negative, then does it affect the confidence interval and how?
Yes, this question is the same as the previous question we answered. If you believe that the distribution of your result is not normally distributed, then you have to depend upon other methods of calculating CI. You can no longer depend upon the normal distribution. What is the difference in bench side study and translation study? Not really the focus of today's session.
You can always refer to the basic course in biomedical research lecture.
Yeah, if you have not already joined, kindly join the basic course in biomedical research, where you will find answers to many of the questions that have been asked today.
Many of them are asking how to calculate confidence intervals.
Okay, so we thought of covering it in another session specifically dedicated to the calculations, but briefly I will tell you some important steps in calculating a CI. So once you get the result, result can be relative risk, odds ratio, hazard ratio, or even prevalence or incidence. So once you get the result, you plug in the formula for standard error. So standard error formula are different for different results. So once you get the formula for the standard error, you simply add 1.96 of that standard error and subtract 1.96 of that standard error to your result to get the confidence intervals. So the general formula, the general format for the confidence interval is your point estimate or result plus or minus 1.96 standard error. Now the formula for the standard error is standard deviation by square root of n. N is the sample size. So if you have a standard deviation calculated for your study, so that standard deviation divided by the square root of n, that is the sample size. So the formula for general formula for confidence intervals will be point estimate plus or minus 1.96 standard error. We will tackle this in a separate session later. Why null value is 1 for RR and 0 for odds ratio? No, I think I said null value is 1 for relative risk and odds ratio, where these both are fractions. So equal quantity in the numerator and the denominator, you divide them, you will get 1. 0 null value is for mean difference and risk difference, where you subtract two quantities. So quantity A minus quantity B, if it gives you 0, then that 0 is null value. So wherever you subtract two things, for example, mean difference, in clinical studies you might have come across mean difference or risk difference. When we are subtracting two quantities, the null value will be 0. When you are dividing two quantities, the null value will be 1. So I hope I cleared that up.
So we have one question from Dr. Vinita Agarwal. Are there conditions when more than 95% confidence interval is required for a study?
Yes, as I said in our previous discussion, sometimes you might want to calculate 98% CI, 99% CI, specifically where you want to be very sure of your result. When you want to be too confident of your results, for example, adverse effects of chemotherapy, where making a mistake could be very serious, right? So you want to be very sure of your results. In that case, a 99 or 98% CI would be justifiable, but generally speaking, 99 out of 100 times, 95% CI is what we recommend.
So we have two announcements to make. So the next session will be on May 13th, that is Thursday, between 4 p.m. to 4:30 p.m. And in the future, we also plan to host a session. There is a question and answer session with scientists from ICMR and National Institute of Epidemiology. And they will be answering your queries related to your own research projects. So we will share a Google form with you to share, so that will enable you to share your queries with us. Okay, so that's all the time we have for today. We hope you thoroughly enjoyed our session, and thank you very much for joining us. So hope to see you again after 2 weeks with another interesting topic. So please check the video description for further reading materials, and don't forget to provide your valuable feedback in the link provided. So it helps us stay relevant to your needs. Thank you.